Well, welcome to this video about using sum and difference formulas. So in this video, we're going to look at those sum and difference formulas and see how they might be helpful in determining the exact value of trig functions for angles that we may not find on our typical unit circle. Okay, multiples of 30, 45, etc. So let's jump in. So we will see that the sum formulas and difference formulas are similar, but they will differ in terms of their signs, S-I-G-N-S. Okay, so let's look at the sum formula. If you have the sign of a sum of two angle measures, then we can actually calculate that by the sine of the first angle measure times the cosine of the second angle measure plus the cosine of the first angle measure times the sine of the second angle measure. Okay, now if you look at the difference formula, the only thing that changes here is the signs in between. Notice that for sine, S-I-N-E, the signs match. If we're adding two angle measures, then these two expressions are being added. If we're subtracting two angle measures, these expressions are being subtracted. For the cosine of the sum of two angle measures, this is a little bit different. We have the cosine of alpha plus beta is the cosine of the first angle times the cosine of the second angle minus the sine of the first angle times the sine of the second angle. Okay, so notice here we have the cosines together and the sines together, and the sine S-I-G-N is different for cosine. All right, so now if we look at the difference formula, you will see that it is the same exact thing except the signs reverse. We're subtracting two angle measures, and between the two expressions we are adding. Okay, now the last one is the least friendly. The tangent of the sum of two angle measures is equal to the sum of the tangents, tangent of the first angle plus tangent of the second, over 1 minus the product, tangent of the first times tangent of the second. Okay, so for tangent, we know tangent is the ratio of the sine and cosine, and it's no different here. Okay, so we've got a ratio going on as well here. Notice that the numerator signs are the same and the denominator sign is different. And if we look at the difference formula, all the signs just switch. So the tangent of the difference of two angle measures is the difference of the tangents divided by 1 plus the product. Okay, so now we've kind of exposed you to the sum and difference formulas. How the heck do we use them? So I've condensed these so we can look at them, but we're going to start off pretty easy, and we're going to find the exact value of each of these expressions. And then it's always good to verify that we have the right thing by using our calculator. Now, what I want to do for this first one is I want to examine what I have. I have the sine of 45 degrees minus 30 degrees, which we're really finding the sine of 15 degrees, okay? But we've got it set up this way so that we can use what we know from the unit circle, and looking at our formulas, we can see that this is a sine of a difference. Okay, so I'm going to come over here to my difference formulas, and I'm going to choose the sine formula, and I am going to use this formula here, and I'm going to identify what is alpha. Okay, so alpha here is going to be 45 degrees, and beta here is going to be 30 degrees. Okay, so I am going to take these measurements and sub them directly into the formula. So every time I see an alpha, I'm going to replace it with 45 degrees. 45 degrees here and 45 degrees here. And everywhere I see a beta, I'm going to replace it with 30 degrees. So 30 degrees here and 30 degrees here. So we are looking at an expression that looks like this. The sine of 45 degrees times the cosine of 30 degrees minus the cosine of 45 degrees times the sine of 30 degrees. Okay, so now I'm going to take each of these individually and evaluate them. The sine of 45 degrees is the square root of 2 over 2. The cosine of 30 degrees is the square root of 3 over 2. And then we're going to subtract from that the cosine of 45 degrees, which is the square root of 2 over 2 again, and the sine of 30 degrees, which is 1/2. So I'm going to replace all of those things with the appropriate value. So you see? Now notice the sine and cosines went away because I evaluated them. I use that function. I don't need that function any longer. Now I'm going to take these first two values and multiply them together, and the second two values and multiply them together. So remember, I'm multiplying fractions, meaning I can multiply straight across the numerator times the numerator and the denominator times the denominator. So here I have the square root of 6 over 4. And here I have the square root of 2 over 4. Okay, and so all we can do with that is really combine it into one fraction. So we would end up with the square root of 6 minus the square root of 2, all divided by 4. Okay, now if we want to double check that on our calculator, what we're going to do is we're going to input that expression. And remember, if I do that, you want to keep your numerator in parentheses. Okay, the square root of 6 minus the square root of 2, all divided by 4, should be about 0.2588. And then if you take the sine of 15 degrees, you should end up with exactly the same value of 0.2588. Okay, let's move on to the second example here. All right, the cosine of 45 degrees plus 240 degrees. Okay, notice that what we're really finding here is the cosine of 285 degrees. We don't know this from our unit circle, but by breaking it into pieces that we do know, we can evaluate this exactly. Okay, so notice that this is a sum. If you look at this expression here, it's a sum, so it's going to be one of these formulas, a sum formula, and it's the cosine formula. So we are going to use this formula right here. That means that I need to identify my alpha and my beta. Okay, alpha is going to be 45 degrees, and beta is going to be 240 degrees. Now I can take those and sub them in for alpha and beta throughout my formula. So the cosine of alpha will become the cosine of 45 degrees. The cosine of beta will become the cosine of 240 degrees minus the sine of alpha, which is the sine of 45 degrees, times the sine of beta, which is 240 degrees. So we have something that looks like this. And now the next step will be to evaluate each of those pieces. Take the cosine of 45 degrees and evaluate that. We know that to be the square root of 2 over 2. And then the cosine of 240 degrees, that will be negative 1/2. Okay. Then we have the sine of 45 degrees, which is the square root of 2 over 2, and the sine of 240 degrees, which will be negative rad 3 over 2. Okay, when we put that all together, we have these values. So we want to go ahead then and multiply them and simplify. So those first two here, we end up with negative rad 2 over 4 minus negative rad 6 over 4. Okay, but that minus a negative will end up being a positive. So we end up with negative rad 2 over 4 plus rad 6 over 4, which is the same as rad 6 minus rad 2 over 4. Looks an awful lot like what we got before. All right, so same thing. We should get the same decimal approximation when we crunch cosine of 285 in our calculator. So let's try it. Cosine of 285 is 0.2588. That means that we did it right. Let's do this last example in degrees. Now remember, tangent is the, quote, fun one, right? Because we have this expression that is not as clean as the others. We have a fraction as our expression. We have a difference. Okay, so what we're doing is we're really evaluating the tangent of 105 degrees, which is 135 degrees minus 30 degrees. So we're going to use this formula right here. And we're going to identify our alpha to be 135 degrees and our beta to be 30 degrees. Now, we're going to substitute all of those things into the formula. So the numerator will become tangent of 135 degrees minus the tangent of 30 degrees over 1 plus the tangent of 135 degrees times the tangent of 30 degrees. Okay, now that is pretty ugly, but it is what it is. Okay, so let's go ahead and evaluate. Hopefully you know that the tangent of 135 degrees is going to be -1. So I will go ahead and replace both of these expressions with -1. And the tangent of 30 degrees is going to be square root of 3 over 3. So let's go ahead and replace all of those. All right, and now let's go ahead and clean this up a little bit. Notice that what I did here was I just got common denominators. This -1 and the square root of 3 over 3, I just multiplied this by 3 over 3. So I got a common denominator. All right, and I did the same thing here because this product here is negative rad 3 over 3. And then if I multiply this by 3 over 3, then I can actually put those together. Okay, and so the next step in cleaning this up, just in case you have a teacher that's going to want the simplified form here, when I clean this up, I am going to see that every term in the numerator and the denominator is divided by 3. I can get rid of those denominators by multiplying the top and the bottom by 3, and all of those denominators go away, and that immediately makes things look a lot nicer, because all of these denominators just go away. So I have -3 minus rad 3 over 3 minus rad 3. Okay, so maybe your instructor will be happy with that answer. And this is where you just really need to know their preference, and I can't really advise you there. Okay, so then if not, because sometimes we want to get rid of all radicals in the denominator, and if that's the case, we need to multiply by the conjugate of the denominator. So let's make a little bit of room, and let's continue this. Remember that what we would do here is multiply by the conjugate of the denominator, and by doing that, we're going to get rid of the radical in the denominator. 3 times 3 is 9. 3 times the square root of 3 is 3 rad 3. Negative rad 3 times 3 is negative 3 rad 3, and so those will cancel. And then in the back, we would have -3. Now on the top, we have something slightly different because our signs are a little bit different. We have -3 times 3, which will be -9. -3 times rad 3, which is -3 rad 3. Negative rad 3 times 3, which is another -3 rad 3. And then finally, -3. So all of that stuff put together looks like this. Now I can put these terms together on the bottom, the 9 minus 3, and I can also put the -9 with the -3 on the top. And it's going to kind of look like this. -12 minus 6 rad 3 all over 6. Now if I divide that 6 out, I'm left with a final answer of -2 minus the square root of 3. Now you're going to have to talk to your instructor and find out where in this process they are happy with the answer being simplified too. Okay, so that is something I can't answer for you. You'll have to figure it out with them. Okay, we're going to break and we're going to come back with some more exact values in the second video.